Okay, let's go over some questions about matrix transformations. This is example 1 on page 64 of the text. I'm just going to add some more details there. So suppose A is this matrix given here, 1, -3, 3, 5, -1, 7. And then we're going to consider the linear transformation T of x is A times x. Now this T is going to define a linear transformation from R2, I know that because there's 2 columns in A, to R3 because there's 3 rows in A. Right? A is a 3 by 2 matrix, and so T defines a map from R2 to R3. So I can compute what T of x is. So T of x1, x2 is this matrix times the vector x1, x2. And so remember the way matrix multiplication works, and I get x1 minus 3x2 in the first component, 3x1 plus 5x2 in the second component, negative x1 plus 7x2 in the third. So the first question that we want to consider is find T of u, where u is the vector 2, -1. And so this is just asking us to plug in the vector u into the map T. And so I just need to take that matrix A and multiply it by u. And I get 2 plus 3 is the first component, 6 minus 5 is the second, and -2 minus 7 is the third. So this is 5, 1, -9. Part B asks us to find the vector x, whose image under T is the vector b, which is given by 3, 2, -5. This is just asking us to solve the equation T of x equals b. In other words, solve the linear system AX equals b. So row reduce the augmented matrix and then find the solutions. So the augmented matrix is the one given here. I just write the coefficient matrix A, this vertical line to remind me it's an equals, and then the vector b. First step of row reduction, I look at the leftmost non-zero column. Top entry of that column is going to be our pivot position. It's already non-zero, so I put a box around it, and that's the pivot. That's what we're going to use to clear off all the entries below. So I can kill off the 3 by replacing row 2 with row 2 minus 3, row 1. And kill the minus 1 by replacing row 3 by row 3 plus row 1. There's our pivot, and we cleared out all below. And now I move to the next leftmost non-zero column of the submatrix there. That 14 is non-zero, it's going to be our pivot. I'm going to use it to kill off the entries below. I can achieve that by taking row 3 and replacing it with row 3 minus 4/14, row 2. That doesn't change the first 2 rows, and it actually zeroes out the last row. I get 0, 0, 0. And now I'm in echelon form. Okay. So since I'm actually interested in the solutions, I'm going to continue to push it to reduced echelon form. Notice in the echelon form, I see that the rightmost column of the augmented matrix is not a pivot column, and so in particular this linear system does have an equation, a solution. I'm going to take that pivot 14 and I'm going to divide by 14 to turn it into a leading 1. And I need to do that for the whole row. And so the second row becomes 0, 1, -1/2. There's my 2 pivots. I'm going to use the 1 to kill the minus 3 above it. I can do that by taking row 1 and replacing it with row 1 plus 3, row 2. That changes row 1 to 1, 0, 3/2, keeps row 2 the same. And now there's my pivots, and I'm in reduced echelon form. And so notice I have pivot columns in columns 1 and 2, which tells me x1 and x2 are basic variables. So in particular, I can just write down what they are in terms of the numbers. In this case, I have no free variables. So x1 is 3/2 and x2 is -1/2. Or equivalently, the vector x is 3/2, -1/2. Part C asks is there more than one vector x whose image under this map T gives us that vector b? This is the same as asking if ax equals b has more than one solution. And so remember, we can tell if a linear system which is consistent has more than one solution. Well, it's just basically asking, does it have a free variable? Right? And we saw that the columns 1 and 2 were pivot columns, which told us x1 and x2 were basic variables, and so there were no free variables. So that tells us there's exactly one x whose image under T is b. Part D asks, is the vector c given by 3, 2, 5 in the image of T? This is just asking if T of x equals c has a solution, or equivalently, does ax equals c have a solution? Is it consistent? So you can just row reduce the augmented matrix, where you write the coefficient matrix A and then the column vector C. So let's do that. There's our pivot again. I'm going to kill off the entries below, so I can kill off the 3 by replacing row 2 with row 2 minus 3 row 1. I can kill off the minus 1 by replacing row 3 with row 3 plus row 1. And then there's our pivot cleared out below, and this 14 is our next pivot. We're going to kill off the 4 below it by replacing row 3 with row 3 minus 4/14 row 2. First two rows stay the same, and the last row becomes 0, 0, 10. And so now I've put boxes around my pivots, and I notice that in the augmented matrix, the rightmost column is a pivot column. And so then the existence and uniqueness theorem tells us this linear system is inconsistent. It has no solution. That means that C is not in the image of the linear transformation T.